A journey through dreams and light, a dreamlike space documentary. Close your eyes, not to sleep, but to see. Tonight, you're going on a journey. Not in a spacecraft built of metal and fire, but in something far more powerful. Your imagination, riding on waves of light that have traveled 2.5 million years just to reach your eyes. You're lying on your back, staring up at the night sky. The air is cool. The world around you has grown quiet. And there, barely visible to your naked eye, is a small patch of light. Soft, hazy, ancient, Andromeda. Most people walk past it their entire lives, never knowing it's there. But you see it now. And as you watch, something extraordinary happens. The light begins to grow, brighter, closer. The stars around it start to blur as your perspective shifts, pulling you upward, away from Earth, through the atmosphere, past the Moon, beyond Mars and Jupiter, out into the vast darkness between worlds. You're traveling now. Not through space as astronauts know it, but through the space between moments, where time bends and distance becomes meaningless. And ahead of you, growing with every heartbeat, is Andromeda. This is not a documentary about facts and figures, though those will come. This is a dream, a vision of what it might feel like to leave everything you know behind and journey across the cosmic ocean to our nearest galactic neighbor. Tonight, you won't just learn about Andromeda, you'll go there. The first thing you notice as you leave Earth behind is the silence. Not the absence of sound. There was never sound in space to begin with. But the absence of everything familiar. No wind, no voices, no hum of electricity or distant traffic. Just you, suspended in an infinite darkness sprinkled with diamonds. You look back, and Earth is already shrinking. That blue marble that contained your entire existence, every person you've known, every place you've been, every moment of your life, is becoming a dot, then a point of light, then indistinguishable from the stars around it. You are truly alone now. But ahead is something worth the solitude. As you drift through the solar system, you pass the giants. Jupiter, with its swirling storms that could swallow Earth whole. Saturn, wearing its impossible rings like a crown. Uranus and Neptune, those distant ice giants that humanity has barely glimpsed. They're all falling away behind you now. The sun itself, that fierce burning sphere that has warmed every moment of human history, begins to dim. Not because it's dying, but because you're leaving it behind. Soon it becomes just another star in the firmament, no brighter than its neighbors. This is when the true scale of your journey begins to reveal itself. Between stars, there is nothing. Vast, empty voids that stretch for years of travel, even at the speed of light. And you're crossing these voids, one after another, watching as the familiar constellations, Orion, the Big Dipper, Cassiopeia, slowly shift and distort. You're seeing the Milky Way from the outside now, our galaxy, that grand spiral of 200 billion stars, spreading out behind you like spilled milk across a cosmic table. You never realized how beautiful it was. You were always inside it, unable to see the full picture. But now, as you pull away, you see our galaxy for what it truly is, a delicate structure of light and dust, spinning slowly through the darkness. And you realize something profound. You're not just traveling through space, you're traveling through time. Every light year you cross takes you deeper into the past. The light you see from distant stars isn't showing you what those stars look like now, but what they looked like when that light began its journey. The light from Andromeda that first caught your eye. It left that galaxy 2.5 million years ago, before humans existed, before Homo sapiens walked the earth, when our ancestors were still learning to use stone tools. You're chasing ancient light. Time passes differently out here. Your sense of minutes and hours has long since evaporated. There's only the journey, the slow, steady drift through the void. And then, gradually, you notice it. That small patch of light you saw from Earth is growing. At first it's imperceptible, a slight brightening, a subtle expansion. But as you continue forward, it becomes undeniable. Andromeda is getting closer. What once looked like a smudge, a blur, a ghost of light, is beginning to take shape. You can see structure now, not just a glow, but layers, depth, complexity. You're approaching a galaxy. Your galaxy, the Milky Way, is now a distant memory behind you, a spiral of light that grows fainter with every passing moment. But ahead is an entirely new world. 1 trillion stars, each one a sun, each one potentially surrounded by planets. Worlds upon worlds upon worlds, more numerous than all the grains of sand on all the beaches of Earth. And you're going to see it up close. You take a breath, though there's no air here to breathe, and continue forward, into the light. The first stars of Andromeda's halo greet you like sentries. These are the ancient ones, red dwarfs that have burned for billions of years, far longer than our own sun has existed. They drift in the outer regions of the galaxy, moving in slow, elliptical orbits that take millions of years to complete. You pass between them, these lonely sentinels, and each one feels like a milestone. You're no longer in the void between galaxies. You're inside something now. But Andromeda's halo is deceptive. It feels empty, almost as sparse as the intergalactic void you just crossed. The stars here are spread so far apart that you could travel for weeks without encountering another one. Yet you can feel the galaxy's presence, its gravity, its mass, like a great sleeping giant, aware of your approach. As you drift deeper, the halo begins to reveal its secrets. You pass through streams of stars, long, thin ribbons of light stretching across the darkness. These are the remnants of dwarf galaxies that Andromeda consumed long ago, torn apart by tidal forces and scattered across the halo like cosmic breadcrumbs. Each stream tells a story of destruction and absorption. Entire galaxies, once independent, now reduced to trails of stars orbiting their conqueror. Andromeda has been feeding, growing, becoming larger by devouring its neighbors. And as you travel through these stellar graveyards, you wonder, when the Milky Way and Andromeda eventually collide, will our galaxy suffer the same fate? Will the sun and all its planets become just another stream in some future halo? But you push the thought aside. That collision won't happen for billions of years. Right now, you're focused on the present, or rather, the past. Because what you're seeing, what you're experiencing, happened 2.5 million years ago. You're witnessing Andromeda as it was when humanity was still in its infancy. The galaxy you see now has already changed. Stars have been born and died. Planets have formed and possibly been destroyed. Entire civilizations might have risen and fallen. But their light hasn't reached you yet. You're chasing ghosts. As you continue inward, the density of stars begins to increase. What was once a scattering of ancient red dwarfs becomes a constellation of blue giants, yellow suns, and brilliant white stars. The halo is giving way to something more substantial. The disk. Andromeda's main disk spreads out before you like a vast cosmic carousel. It rotates slowly, majestically, its spiral arms trailing through space like the arms of a dancer frozen in motion. And the colors. You've seen pictures of galaxies, of course. Images from Hubble and Webb showing distant spirals in stunning detail. But those were photographs, processed, enhanced, colored artificially to reveal details invisible to the human eye. This is different. This is real. The spiral arms glow with a soft blue light, regions where massive young stars are being born by the thousands. These stars are hot, so hot that they shine with an almost electric intensity, lighting up the surrounding gas clouds and making them glow like cosmic neon signs. Between the arms, older yellow and orange stars dominate, giving those regions a warmer, calmer light. These are the veterans, the long-lived stars that have seen billions of years pass by. And scattered throughout, like embers in a dying fire, are the red giants, stars nearing the end of their lives, swelling to enormous sizes as they prepare for their final transformation. You drift above the disk, looking down at this vast pinwheel of light, and you're struck by a thought. Somewhere down there, on one of those trillion stars, there might be a planet, and on that planet, someone might be looking up at their night sky, seeing a small patch of light they call the Milky Way. Are they dreaming the same? Dream! Are they wondering what it would be like to travel here, just as you wondered what it would be like to travel there? Or are you alone in this? The only consciousness in either galaxy capable of such dreams? You don't know. And perhaps that's the most beautiful and terrifying part of the journey. As you descend toward the disk, you notice something strange. The outer edges of Andromeda are moving faster than they should be. If the galaxy consisted only of the matter you can see, stars, gas, dust, then the outer regions should be moving slowly, barely held by gravity. But they're not. They're moving as if something massive and invisible is holding them in place. Dark matter. You can't see it, can't touch it, can't detect it in any way except through its gravitational effects. But it's there, surrounding the galaxy in an enormous halo far larger than the visible disk. This invisible substance, whatever it is, makes up most of Andromeda's mass. The stars you see, the gas clouds, the planets and moons and asteroids, all of it is just the foam on top of a vast dark ocean. You're floating through a galaxy you can barely comprehend, where most of what exists is hidden from view. It's humbling. And as you prepare to dive deeper, to explore the heart of this cosmic giant, you feel a mix of excitement and trepidation. What will you find in the spiral arms? In the core? What secrets does Andromeda hold? You're about to find out. You descend. The disk rises up to meet you, and suddenly you're no longer above Andromeda looking down. You're in it, swimming through rivers of stars, dodging clouds of dust and gas, surrounded on all sides by the lights of a trillion suns. This is nothing like the empty void you crossed to get here. This is dense, chaotic, alive. You enter one of the spiral arms, a region of intense star formation where the galaxy is at its most creative. Here, enormous clouds of molecular hydrogen collapse under their own gravity, fragmenting into smaller and smaller pieces until they ignite, becoming new stars. You drift toward one of these stellar nurseries, and it takes your breath away. A nebula, vast, glowing, stretching across dozens of light years in every direction. The gas glows with a soft pink light, illuminated by the ultraviolet radiation of newly formed stars hidden within. You can see dark pillars of dense dust rising like mountains against the glowing background. These are the places where the next generation of stars is being born. You move closer to one of these pillars, and at its tip, you see it, a protostar, not yet fully formed, still gathering material from the surrounding cloud, but already beginning to shine. In a few million years, this will be a star like the Sun. It might have planets. One of those planets might have oceans, atmospheres, life. But right now, it's just a glowing ember in a cosmic womb. You watch for a moment, though moment has lost all meaning in this timeless place, and then move on. The spiral arm is full of surprises. You pass clusters of young blue giants, massive stars that burn so fiercely they'll only live for a few million years before exploding as supernovae. They're grouped together, siblings born from the same gas cloud, destined to die young and violently. You pass older yellow stars, more sedate and stable, quietly converting hydrogen to helium in their cores. These are the long-lived ones, the stars that will burn for billions of years, providing steady warmth to any planets that orbit them. And you pass red dwarfs, small and dim, barely visible against the brighter lights around them. But these are the true survivors. They'll outlive all the others, burning slowly and steadily for trillions of years, long after galaxies themselves have evolved beyond recognition. Between the stars, dust and gas swirl in complex patterns, Some of it is pristine hydrogen left over from the Big Bang. But much of it has been enriched by previous generations of stars, carbon forged in red giants, oxygen created in massive stars, iron produced in supernova explosions. This enriched material will become part of new stars and planets. The cycle of death and rebirth continues, generation after generation, each one slightly more complex than the last. You reach out, impossible as it seems, and imagine touching this cosmic dust. Somewhere in this material are the atoms that might one day become part of a living creature. Perhaps even a conscious being, wondering about the universe just as you are. As you travel deeper into the spiral arm, you notice something unsettling. Scattered among the beautiful glowing nebulae and shining stars are darker regions, voids where even starlight seems to disappear. You approach one carefully. It's a molecular cloud, a dense, cold region where dust blocks out all light. These clouds can be dozens of light years across, massive enough to contain the material for thousands of stars. You enter the cloud, and for the first time since leaving Earth, you experience true darkness. Not the darkness of empty space, which is always filled with distant starlight, but absolute, complete darkness. No light penetrates here. For a moment, you feel a pang of fear. Lost, alone, trapped in a cosmic void where even the stars can't reach. But then you remember, this isn't death. This is potential. These dark clouds are the places where stars are born, where planets form, where life might one day emerge. You're not in a void, you're in a womb. And sure enough, as your eyes adjust, or rather, as your dream vision shifts to perceive what eyes cannot, you begin to see faint glows. Infrared light from protostars hidden within the cloud. They're forming right now, collapsing under gravity, heating up as they contract. You emerge from the dark cloud back into the light, and it feels like being born yourself. The journey through the spiral arm continues. You pass supernova, remnants, expanding shells of gas ejected by exploded stars, still glowing with the heat of their violent deaths. Inside these remnants, exotic elements are being created. Gold, platinum, uranium, all the heavy elements that can only form in the extreme conditions of a supernova. You pass planetary nebulae, beautiful symmetric shells of gas expelled by dying stars. These are the final breaths of stars like the sun, their outer layers puffed off into space, leaving behind tiny white dwarf cores. And everywhere, there is motion. Stars orbiting the galactic center, gas clouds collapsing and expanding, shock waves from supernova explosions rippling through the interstellar medium. Nothing here is static. Everything is in flux. The spiral arm is not a fixed structure, but a wave, a density pattern moving through the disk, triggering star formation as it passes through clouds of gas. You realize that, if you could watch this in fast forward, the galaxy would look less like a solid object and more like a living organism, breathing, pulsing, evolving. After what feels like both seconds and centuries, you complete your traverse of the spiral arm and emerge into the calmer region between the arms. Here, the star formation has quieted. The bright blue giants are absent. Instead, you're surrounded by older, cooler stars. Yellow dwarfs, orange giants, red dwarfs. This is where stable planetary systems are more likely to exist, where worlds might orbit their stars for billions of years undisturbed, long enough for life to evolve and flourish. Somewhere in this vast expanse, there might be an Earth-like world, perhaps orbiting one of those yellow stars in the distance, perhaps covered in oceans, with continents and mountains and clouds, perhaps even inhabited. You search the surrounding stars, wondering if you could identify such a world from this distance. But the dream doesn't grant you that vision. Some mysteries remain hidden, even in dreams. So you continue onward, toward the one place you haven't yet explored, the core. As you approach Andromeda's center, everything changes. The stars grow denser. What was once a scattering of lights becomes a crowd, then a swarm, then a blizzard of stellar fire. You're moving through a region where stars are so tightly packed that their light blends together, creating a continuous glow. If a planet existed here, its night sky would never be dark. The light from millions of nearby stars would illuminate it constantly, casting overlapping shadows in every direction. But planets are rare here. The gravitational chaos at the galactic center makes stable orbits difficult. Any world unlucky enough to form here would likely be torn apart or ejected into space. You're entering the central bulge now, a vast, spherical region of old red stars that surrounds the very heart of the galaxy. These stars are ancient, formed in the first billion years after the Big Bang, when the universe was young and the only elements available were hydrogen and helium. They've been orbiting the galactic center for billions of years, witnesses to everything Andromeda has become. And at the center of it all, hidden within the blinding light of millions of stars, is something that shouldn't exist. A darkness so deep that not even light can escape. You feel it before you see it. A pull, a distortion in the fabric of space itself. The supermassive black hole, M31 as astronomers call it, is a monster. It contains the mass of 140 million suns, compressed into a region smaller than our solar system. Its gravity is so intense that it warps space-time into a deep well from which nothing, not even light, can climb out. As you drift closer, the stars around you begin to move faster. They're orbiting the black hole, accelerating as they approach, reaching speeds that would make interstellar travel seem leisurely by comparison. Some of these stars orbit so close to the black hole that they complete a full revolution in just a few years. If you watch them in fast forward, they would appear to dance around an invisible point, held by a force they can never escape. You watch one star pass dangerously close to the black hole's event horizon, the point of no return. For a moment, it seems like it might fall in, but it swings around at the last second, flung back out into space by its tremendous velocity. It survived. This time, others haven't been so lucky. Over billions of years, countless stars have drifted too close and been torn apart by tidal forces. Their material, gas, plasma, stellar atmospheres, spirals into the black hole, forming an accretion disk that glows with X-rays. But right now, the black hole is quiet. It's not actively feeding. The accretion disk is thin and dim. M31 is sleeping. Still, you can sense its presence. The way space bends around it, the way time slows near it. If you were to fall toward the event horizon, to an outside observer, you would appear to freeze, your image stretched and distorted, never quite crossing the boundary. But from your perspective, you would fall in normally, watching the universe outside compress into a bright ring of light, the last photons escaping the black hole's gravity well, and then nothing. Whatever lies beyond the event horizon is hidden from the universe. Information cannot escape. Light cannot escape. Not even time, in any meaningful sense, exists there. The black hole is a one-way door to nowhere, or everywhere. Theories differ. You resist the urge to move closer. Even in a dream, some boundaries should not be crossed. Instead, you orbit at a safe distance, watching the stars spiral around this cosmic drain. You think about what this means. Every large galaxy has one of these monsters at its center. The Milky Way has one. Andromeda has one. Billions of other galaxies across the universe have them. Are they connected somehow? Are they the reason galaxies exist in the first place? Did they form first, and the galaxies built up around them? Or did the galaxies form first, and the black holes grew from the material that fell to the center? No one knows for certain. Black holes remain one of the greatest mysteries in the universe. We can observe their effects, the way they bend light, consume matter, generate radiation, but we can't see inside them. The laws of physics, as we understand them, break down at the singularity. Some physicists believe black holes might be portals to other universes. Others think they might be gateways through time. Still others believe they're simply endpoints, places where matter is compressed out of existence. Whatever the truth, you're grateful to be observing from a distance. After one final orbit around M31, you turn away from the core and begin your journey outward. You've seen the heart of Andromeda. You've witnessed its violent, chaotic center where stars dance around an invisible abyss. Now it's time to explore what lies on the outskirts. As you move away from the bright central regions of Andromeda, you notice something unexpected in the darkness. Small galaxies. Dozens of them, scattered around Andromeda like moons around a planet. These are the satellite galaxies, dwarf systems containing millions or billions of stars, orbiting the larger galaxy over billions of years. You approach one of them. M32, a compact elliptical galaxy that orbits close to Andromeda's disk. It's small compared to its host, but by any other measure it's enormous. Millions of stars packed into a dense core, glowing with an ancient golden light. M32 looks peaceful from a distance. But as you draw closer, you see signs of violence. The outer edges of the dwarf galaxy are being stripped away. Long streams of stars trail behind it like a comet's tail, pulled from the galaxy by Andromeda's tidal forces. Over billions of years, M32 is being slowly consumed, its stars stolen one by one and added to Andromeda's halo. Eventually, nothing will remain. M32 will disappear entirely, merged into the larger galaxy, its stars scattered and lost. You feel a pang of sadness watching this slow-motion destruction. M32 was once an independent galaxy. It had its own structure, its own history, perhaps its own planets and civilizations. Now it's being erased. This is the fate of all small galaxies near large ones. Andromeda is a gravitational bully, pulling in anything that ventures too close. You move on to another satellite, M110, a larger dwarf galaxy with a more diffuse structure. Unlike M32, M110 still shows signs of recent star formation. Blue clusters of young stars dot its edges, indicating that gas is still collapsing to form new stellar generations. But it won't last. M110's gas is being stripped away by its interactions with Andromeda. In a few billion years, it too will be a dead galaxy, its star-forming days over. As you explore the outskirts of Andromeda, you discover more and more of these dwarf galaxies. Some are bright and obvious. Others are so faint they're barely visible, containing only a few million stars spread across thousands of light years. These faint dwarfs are puzzles. Theory suggests there should be hundreds of them orbiting Andromeda, but astronomers have only found a few dozen. Where are the rest? Did they never form? Or are they there but too dark to detect? Some scientists think these missing satellites might be made almost entirely of dark matter, with only a handful of visible stars. Entire galaxies lurking in the darkness, invisible except for their gravitational pull. You drift through this realm of dwarf galaxies and wonder what it must be like to live on a planet in one of these systems. Your night sky would be dominated by Andromeda. Not a faint smudge like from Earth, but a vast spiral filling half the sky, its arms clearly visible, its core a brilliant beacon. You would see tidal streams stretching across the darkness, remnants of other dwarf galaxies that came before, torn apart and scattered. You would know, with certainty, that your galaxy is dying, that your entire world is orbiting a cosmic predator that will eventually consume everything. How would that shape your culture, your philosophy, your understanding of existence? Perhaps it would make you fatalistic, or perhaps it would inspire a sense of urgency, a determination to explore and understand the universe before time runs out. You'll never know. The civilizations that might exist in these satellites remain hidden from view, if they exist at all. As you complete your tour of Andromeda's satellite system, you notice something strange. The dwarf galaxies aren't distributed randomly. They're arranged in a plane, a vast thin disk that encompasses Andromeda's entire halo. This shouldn't be possible. Satellites should orbit in all directions, pulled by gravity into random orbits over billions of years. But these galaxies are aligned, moving in coordinated patterns, almost as if they were created together, all at once, rather than captured individually over time. It's a mystery, one that astronomers in the waking world are still trying to solve. But you don't have time to contemplate it further, because something is happening. You're beginning to pull back. The dream is starting to fade. Andromeda, once so close you could see individual stars, is now receding. You're going home. The journey back is faster than the journey there, or perhaps it only feels that way. You watch as Andromeda shrinks, its spiral arms collapsing back into that familiar hazy glow. The individual stars blend together. The satellite galaxies disappear. The complex structure you explored so thoroughly reduces itself to a simple patch of light. But you're different now. You know what's hidden in that light. You've seen it. The Milky Way grows larger ahead of you. Your home galaxy, which seemed so vast when you left, now feels small by comparison. But it's still beautiful, still filled with its own wonders, its own mysteries. You pass through the halo, greeting the same ancient stars you passed on your way out. They've barely moved. To them, your entire journey was just a moment. The disk of the Milky Way rises up to meet you. You're entering the spiral arms now, passing through familiar constellations that have guided human sailors and dreamers for millennia. There's Orion with his belt and sword. There's Cassiopeia, the celestial queen. There's the Southern Cross, pointing the way south. The sun comes into view, bright, warm, welcoming. Home. You pass the outer planets in reverse. Neptune, Uranus, Saturn, Jupiter. Each one a milestone marking your return to the familiar. And then, finally, you see it. Earth. That blue marble. So small, so fragile, so impossibly beautiful. You descend through the atmosphere, feeling the resistance of air for the first time in your journey. The world solidifies around you. Gravity reasserts itself. You're lying on your back again, staring up at the night sky. The journey is over. Or is it? Because even though you're back in your body, back on Earth, back in the present moment, something has changed. You look up at that faint patch of light, Andromeda, and you don't see a smudge anymore. You see spiral arms. You see nebulae where stars are being born. You see the ancient stars of the halo. You see the satellites orbiting in their strange aligned plane. You see the black hole at the center, sleeping, but never truly asleep. You see all of it, even though your eyes show you only a blur. The dream has ended, but the knowing remains. There's one more part of the dream, a vision of what's to come. You see the sky changing, not in your lifetime, or even in the lifetime of your species as it exists now, but eventually. Andromeda is moving toward the Milky Way, slowly, inexorably. In 4.5 billion years, the two galaxies will collide. You watch it unfold in fast forward, a cosmic ballet choreographed by gravity. First contact. The outer halos merge. Stars from both galaxies begin mixing, but they're so far apart that no collisions occur. Not yet. The spiral arms distort. Tidal forces stretch them, pulling them into long streamers of stars and gas. The cores pass through each other, emerging on opposite sides, then swinging back around for another pass. With each encounter, more material is scattered. More stars are flung into new orbits. More gas clouds are compressed, triggering massive bursts of star formation. The night sky of Earth, if Earth still exists, if the sun hasn't already expanded into a red giant and consumed the inner planets, becomes a chaos of light. New stars being born by the millions, supernovae exploding in brilliant flashes, gas clouds glowing with the light of 1 trillion suns. After several close passes, the two galaxies finally merge. The spiral structures collapse. The organized rotation gives way to chaotic orbits. What emerges is something new. Not a spiral anymore, but an elliptical galaxy. A vast football-shaped collection of stars moving in random directions. Astronomers in the waking world have already given this future galaxy a name, Andromeda. And in this merged galaxy, perhaps, something extraordinary will happen. The burst of star formation triggered by the collision will create billions of new planetary systems. Rocky worlds orbiting yellow suns, gas giants with icy moons, rogue planets drifting through interstellar space. And on some of those worlds, perhaps, life will emerge. Creatures we can't imagine, living under skies we've never seen, asking the same questions humanity has asked since it first looked up at the stars. Where did we come from? Are we alone? What else is out there? And perhaps one of them, billions of years from now, will lie on their back and look up at the night sky of Andromeda. They won't see Andromeda and the Milky Way as separate entities. To them, it will all be one galaxy. Home. But maybe they'll dream too. Maybe they'll wonder what it would be like to travel to another galaxy, far beyond their own. Maybe they'll close their eyes and let their imagination carry them across the cosmic ocean to some distant spiral, just as you did tonight. Because that's what dreamers do. They look at the impossible and say, what if? They look at the darkness and see light. They look at the distance and feel no fear, only curiosity. And so the cycle continues, forever reaching, forever exploring, forever dreaming of what lies beyond. You open your eyes. The night sky is still above you. Andromeda is still there, that faint patch of light barely visible to your naked eye. But now you know. You've been there. You've seen it. You've traveled across 2.5 million light-years of space and time, and you've returned changed. The journey was a dream, yes, but not just a dream, because knowledge is a kind of journey too, and understanding is its own form of travel. Every time you look up at that patch of light now, you won't just be seeing ancient photons that left Andromeda when humanity was young. You'll be seeing 1 trillion stars, a supermassive black hole, spiral arms filled with nebulae and newborn suns, satellite galaxies being slowly consumed, and the vast invisible halo of dark matter that holds it all together. You'll be seeing home, or at least a potential future home. Because one day, not in your lifetime, not in anyone's lifetime for billions of years, but one day, Andromeda and the Milky Way will be the same place. And maybe, just maybe, some distant descendant of humanity will be there to see it. Until then, we have dreams, and light, and the infinite sky. Thank you for traveling with me tonight. Now look up and dream your own journey. The universe is waiting.